Good evening, sir.
Good afternoon. Good afternoon. Okay, you guys can see my screen, okay? मेरा screen देख
Yes, sir.
Yes.
Okay. चालू करते हैं. Last time we stopped at number 7. We stopped at number 7, no? Where were we, बेटा? एक बार थोड़ा सा बताएं. कहाँ थे आप?
Yes, sir. We stopped. We finished 7.
Okay. So just to get ourselves started, let's just have some fun with the rope pulley systems, right? Mass pulley systems. So I'm just going to ask a quick question. Will not be solving any question as such. If you guys can see the screen. So what we have is, we have this arrangement of 6 pulleys. 3 of them are fixed and the other 3 are floating. In other words, they can move vertically up and down. And one single string goes over all the pulleys. Right? One end of the string is connected to the roof, another is connected to the mass, for which the acceleration has been shown to be A2. Okay, and all the pulleys, all the 3 pulleys, the bottom pulleys, they're connected to a plank, which is whether massless or not massless, it doesn't really matter, right? So the question I'm going to ask is fairly simple and straightforward. What is the relationship, geometrical relationship between A1 and A2? In fact, let me ask the question prior to that or before that. Is A1 and A2 independent of each other, or are they dependent on each other? The question is A1 or are A1 and A2? A1 is the acceleration of the horizontal massless plank. A2 is the acceleration of the mass that is hanging at the other end of the string. The question is, are their accelerations geometrically linked or related, or are those 2 accelerations independent? Geometrically,
Sir, dependent.
they are dependent. So what is the relationship, beta?
Sir, A2 greater होगा.
And what will be the exact relationship? Will it be A2 is equals to 3A2, A2 is equals to 3A1, or A1 is equals to 6A2, or A2 is 6A1? What will that be?
Sir, A2 equals to 3A1.
Okay. So your answer is, beta, hold on. Yes, beta. So you said A2 is 3A1. Is that right?
Yes, sir.
A2 is 3A1. So A2, Ruchika, Chavi, what will this be, beta? क्या रहेगा? मनन बेटा रीथिंक करें.
Sir, I'm not really sure, but A2 is equal to 6A1 नहीं होगा.
Sir, वो mass पे dependent. नहीं करेगा।
ओके, तो आपका कहना है कि मैसेज पे डिपेंड करेगा और छवि बेटा आपको क्या लगता है, डज इट डिपेंड ऑन द मैसेज?
अच्छा नहीं, तो 6 A1 ही होगा।
-6 A1। ओके, मैग्नीट्यूड की अगर बात करें, करेक्ट?
यस सर।
ओके, रुचि के बेटा आपका भी यही है?
Yes, sir.
उसका रीज़न एक बार देख लेते हैं ऐसा क्यों है। अगर आप प्लैंक को कर लें या ऊपर मूव कर लें, नीचे मूव कर लेते हैं बेटा, तो ये जो पुलिस है यहाँ आ जाएंगी, तो इतनी एक्स्ट्रा रस्सी यहाँ चाहिए कि एक्स्ट्रा यहाँ चाहिए कि इतनी एक्स्ट्रा यहाँ, तो ये अगर x है तो ये सारे ही x x x x and x। अब हमें एक्स्ट्रा x लेंथ है बिटवीन ऑल दीज 6 पुलीज हमें चाहिए, कहाँ से आएगी? वो फ्री एंड से ही आएगी, क्योंकि अब ये एंड तो स्ट्रेच हो नहीं सकता है, देयर इज़ नथिंग, यहाँ से तो कुछ आ नहीं सकता है, और कहाँ से आएगा? इसी रस्सी से आएगा ना, तो दिस हैज़ टू मूव अप बाय 6x। In other words, A1, A2 is equals to 6A1. Clear? Correct na beta?
हाँ सर.
यस सर।
Okay. आगे बढ़ते हैं, काइनेमेटिक्स पे चलते हैं। So we're gonna start with the 1D motion. 1D motion में we started with some questions on number 7, so let's start from there. And what do we have in this question type? So what we have is a scenario where the particle is moving along one dimension without the change in direction, And once again, we will have to use our standard kinematic equations. V is equals to U plus AT and S is equals to UT plus half AT square to determine the unknown. Okay. And what did I tell you last time? These are two independent equations, and there are only two independent equations available. There are no more than two independent equations. How many variables are there? There are 5 variables. So let me write these equations again. So we have V is equals to U plus AT. Displacement S is equals to initial velocity times the time duration t plus half times AT square. These equations are valid or true for scenario of constant acceleration, not for any other scenario, not when the acceleration is varying. And if you are wondering why that is, go back to how these equations were derived. Obviously, we had taken a graphical method to determine these two equations. But once again, acceleration A is a constant acceleration. Okay, so there are 5 variables: S, U, A, time duration t, and displacement S. Only 2 independent equations, which means you have to know the information about 3 to be able to determine the other 2. Now it's quite possible that, let's say, you are dealing with, you're given initial velocity, you're given final velocity, you're given the time duration, you just have to find the acceleration A, which means you don't even have to worry about the second equation. So here you will be given 3, you can find out the 4th one. In any case, let's go ahead and look at some of the questions. But here, once again, the trick will be, you will not be given the information for final, initial, time duration, and acceleration and displacement for the entire journey, but you will be given some information about the first part of the journey, some information about the second part of the journey. Doesn't really matter, but you will be given information about 3 variables. So just patiently work through those equations and we should be able to get to our desired answer. JEE Advanced, did we attempt this question, JEE Advanced question? I think we had done this. Okay. Let's go to the next one. So what do we have here? So we have, once again, particle is moving along one dimension, but now we're going to have a change in direction. So direction change hogi. ठीक है बेटा? So there will be a change in direction, and once again, you will be given information about 2 or more segments, right? But the acceleration is the same throughout. Acceleration is the same throughout. And what does it tell us about the initial velocity and the direction of the acceleration? Well, they'll be opposite to each other, right? Only then will you have a change in direction. So initial velocity and the acceleration will be in the opposite direction. Now, sign convention will become important because after all, even though it's a one-dimensional motion, the velocity is a vector quantity, acceleration is a vector quantity, displacement is a vector quantity. So we have to make sure that we look out for the signs. So you can choose either direction as positive or negative, and you can choose your origin at any point. You can choose your origin here, and you can choose to call the upward direction as positive y, or positive whatever x, or positive z, doesn't really matter. Or you can choose to have your origin up here and have your direction this way. So this is, let's say, the first choice, this is second choice, and the third choice can be this. So this is what you call as your positive y direction, plus 1. So in this case, let's start with number 1. So if you choose number 1, then tell me about the, if you choose the number 1, tell me the initial velocity, would that be positive or negative? That'll be positive, yes? So you will be positive.
Yes, sir.
Acceleration will be positive or negative?
So negative.
Negative. Okay. Displacement at any time t, will that be positive or negative?
Sir, either.
What is it, Peter?
Sir, either.
Either, yes. It just depends what time we talk about, because displacement is final position minus initial position. Origin doesn't really matter. Correct, no? So the initial position is here. So as long as the particle is above this point, the displacement will be positive. If it falls below that level, displacement would be negative, right? So it can be either positive or negative. If you take the second set of coordinate system with origin at the top of the building and the positive y-axis pointed vertically upwards, then let's quickly look at the u. Will the u be positive or negative? It will be positive, yes. Acceleration again negative, and displacement again it might be positive, it might be negative, right, beta? Now what will be the initial position? I forgot to ask this one. In this one, the initial position, is it positive or is it negative here?
Sir, positive.
Positive. Okay. So in the next one, it can be either positive or negative. Your initial position is 0. Now let's talk about scenario 3. Scenario 3 means if you choose your origin at the top of the building, but this time you're taking your positive y-axis as pointed vertically downwards. So then what will be the sign convention for different variables? U will be positive or negative?
Sir, negative.
Negative. Acceleration is positive?
Yes, sir.
Okay. Displacement again, displacement will depend on whether it is the particle is above that line or below that line, so it might be positive or negative. Initial position is 0?
Yes, sir.
Okay. ठीक. What will be the final position if we are interested in the scenario where the particle hits the ground, right? So the final position as per this coordinate system, let's say the total
So
height
zero.
h. The final position in this one is 0. Here it is what? Plus
Sir, minus.
minus h. and here of course it is your plus h. Okay, good.
Excuse me, sir.
Yes, beta.
Sir, the first case is the positively or negatively? Yes.
फर्स्ट केस में
Sir, S positive.
अच्छा,
Sir, ये origin तो sir ground पर है ना?
ओरिजिन ग्राउंड पे अभी देख लेते हैं. So here is the origin. This is your xi, right? And let's say you are talking about this point. You're talking about time duration in which the particle has just managed to get to this point. So what is the displacement here? Positive or negative? Positive. Yes, Pitaji?
Yes, sir.
Okay. Now let's think about this scenario where it is at the bottom. Let's say this is the xf. The xf is 0. xi is positive. This becomes a negative number.
Sir, मुझे लगा sir instantaneous displacement.
Instantaneous displacement. Okay. So instantaneous displacement
Sir,
will
मतलब
have the same sign as the velocity at that time. So the velocity is positive going up. The velocity is negative coming downwards. Okay. Displacement ds, differential displacement, would be positive when it's going up. Once again, displacement is final position minus initial position.
Sir, मुझे लगा था आपने position पूछा है with respect to origin.
अच्छा. Okay. Position की भी बात की थी अपन ने. So we spoke about position as well. That's fine. I think you guys are clear. Any doubts, Ruchika, Chavi?
No, sir.
Okay. Since this is a 2022 question, we'll pay our respects to it and let's quickly go through it. Is it okay if I start writing the steps down? Or would you guys want me to wait?
So just a minute.
This is 6 seconds.
6 seconds. मनन बेटा आपका भी कितना आया?
Sir, 6 seconds.
6 seconds.
Yes, so 6 seconds.
Wonderful. Check कर लेते हैं in case you guys had a better method than what I'm writing down. ऐसे कुछ लिखा है आप लोगों ने भी?
Yes.
Yes.
अच्छा. Let me see if I'm doing it right. So this is your 48. So this is, I'm gonna quickly cancel it out here. So we have, so 24 plus 20, so that's 44. 44 divided by, now, this is u, no, this is not 4. This is 100. This is minus 100. So what do we get? Minus 1, or it's 1 will be in the other side. So 120 divided by 20. Okay. So we're gonna jump to JEE advanced questions. Let's take a look at some of these questions. करें बेटा. बड़ा ही patiently work through करें equations में. There are no surprises, right? The science is pretty well nailed down. Equations are pretty standard. Now it's just a matter of figuring your way around the equations. It's equally important to train the mind to be very alert but very, very calm. No competition.
So it's CR.
CR.
So T over T Gauss is again eliminate the second number.
Okay. So let's look at Shavi. Is that okay, beta, if I discuss, or shall I wait?
No, that's okay. I'll do parallelly.
ठीक. So beta, time taken to reach the highest point. V is equals to U minus GT. Right. So V is equals to U minus GT. The V final position when it reaches the topmost point. This point V is 0, no? So if you want to find out the time duration for this segment where it starts from the origin and it reaches the topmost point, so there V is 0, U is U. Again, positive direction has been taken to be vertically upwards, so acceleration is minus g, that's why I've written it that like that. So your t becomes u by g. Okay. Now let's talk about the full journey, starting from the top of the tower and with the particle landing at the bottom or landing on the ground. So if you take this entire journey, for this entire journey, your time duration t is n times u by g, right? N times u by g. Initial velocity is again u. Time is n times u by g. Acceleration is minus g again. T square is nu by g square. And what is the displacement? Final position minus initial position. Final position is minus h. Initial position is 0, so it is minus h. Yes, Peter? Is that clear?
Yes.
Okay, so if you were to solve it, I think we will get minus 2gh is equals to 2nu square minus n square u square. So if I were to take minus from here, so you will get this. So what do we have? If I take u square out, n out, so you get nu square, u minus 2. Sorry, n minus 2, not u minus 2, n minus 2. Option C. Let's look at the NT Abhyas question. Any questions from there? Any questions from the previous or any doubts on the previous question? Yes, Peter. Okay, let's go ahead with this one. So we have to figure out the time taken from the point when the stone is released from that height, h.
Sir, n equals to 2R.
N equals to 2r.
Yes, it's a 2R.
Is that how you guys wrote your equations as well?
Yes.
Okay.
Yes, sir. Same answer.
Okay, wonderful. Let me just find the questions from JEE 2019 and 2020. I, I found 2019 questions fairly okay. Even 2020 was not bad. Let's look at this question.
सर आप स्क्रॉल डाउन कर सकते
एक बार फटाफट ड्रॉ आउट कर लें क्योंकि थोड़ा सा लेंदी है क्वेश्चन, तो ये ऑप्शंस बी सी डी एक बार फटाफट ड्रॉ आउट कर लें अपने पेपर पे।
एक्सक्यूज मी सर
यस बेटा।
सर जो बी ऑप्शन है सर उसमें जो सर जो वेलोसिटी एक्सिस है उसमें जो दो पॉइंट्स के जहाँ ग्राफ मीट होगा सर वो इक्वल डिस्टेंस पे क्या ओरिजिन से
जो वेलोसिटी का दिखाया है जो दो पॉइंट्स,
यस
श्योर
सर सेम है
looks like it from what I can tell.
सर अगर सेम नहीं है सर तो वो आंसर है
अगर सेम नहीं है तो वो आंसर
सर तो वो आंसर हो जाएगा
हो जाएगा। अच्छा,
सर सॉरी सर ए होगा इसका
Yes, sir. A होगा.
ओके।
सर एक बार आप सीडी दिखाओगे फिर से?
श्योर बेटा।
हाँ सर ए होगा।
ओके, रुचिका बेटा एक्सप्लेन करें ये क्यों होगा।
Sir, third equation of motion v square is equals to u square plus 2gs या minus 2gs अगर इसमें लेंगे तो sir जो ग्राफ प्लॉट होगा that will be parabolic और sir अगर हम डाउनवर्ड डायरेक्शन को नेगेटिव मानते हैं तो sir उसके हिसाब से sir ये होना चाहिए।
अच्छा, तो डाउनवर्ड डायरेक्शन को नेगेटिव माना है, पॉजिटिव माना है इन्होंने।
सर डाउनवर्ड्स को नेगेटिव माना है
नेगेटिव कैसे पता? यहाँ से चालू हो रहा है हाई टच।
सर जब एक्स से जीरो जाता है तो ग्राफ सर बैक लेफ्टवर्ड डाल जाते हैं तो
Right. So the equation is v square is equals to u square. डाउनवर्ड को अगर नेगेटिव माना है, डाउनवर्ड को अगर नेगेटिव माना है, then your h will be taken, should be taken as negative as well. So it will be 2 acceleration would be minus g. So we are saying that the positive y is taken to be pointed upwards. So acceleration is minus g and your displacement after the particle is released, the particle simply is coming down. So which means displacement is negative, right? So final position at any time t minus initial position. Final position is negative if you assume your origin to be at the top. If you assume your origin to be the top, doesn't really matter. Even if you assume the origin at the bottom, still it will be negative. There will be minus h, so 2gh, v square is equals to 2gh. तो ये कौन से वाला पैराबोला है रुचिका बेटा? इज इट x is equals to 4ax is equals to y squared? Is that what it is?
Yes, sir.
Okay. ठीक. And then all of a sudden when it hits the ground, its velocity is reversed. Now depending on the collision, whether the collision is elastic or partially elastic. Elastic means the energy is conserved. So if it goes in with certain velocity, it comes back with the same velocity. If it's not perfectly elastic, then the velocity after bouncing back would be less than the velocity hits the ground. Okay.
सर ये तो सर नॉट परफेक्टली इलास्टिक होगा ना सर, क्योंकि इसमें सेम हाइट पे नहीं पहुंचता।
Correct. So obviously, as you rightly pointed out, this seems to be smaller. So we are assuming that this is a partially inelastic, partially elastic, whichever way you might want to call it. Okay, any other doubts? No doubts. Okay. ठीक है बेटा, आगे चलते।
Sir,
Yes, ma'am.
I'm not completely sure the equation that you wrote, y square is equal to 4x, what that means.
Okay, so I'm just going to draw it out here. हम ये मान के चल रहे हैं, जैसे किसी हाइट से आपने इसको रिलीज किया है, तो I forget, was the h measured from the ground or was h the distance? Let me go back. Sorry, I should have paid attention there. How was h defined? Was it measured from the
ground? Sir, altitude है बोल को।
Okay, so in this case, let's rewrite it carefully. Let's say this is measured from the ground, right? So the origin is here, this is the origin, and let's say this is taken to be plus y. The particle initially is at the height, let's say h, or let's call it, that's fine, let's call it, I'm just going to refer to them as capital H. Okay, so this is capital H, and this is the height h at any point of time t. Let's say the particle is here, this is the height h at time t, right? So what will be the velocity? The velocity would be when it's falling downwards, when it's coming downwards, the velocity is negative. And what will be the magnitude? Magnitude will be, so velocity will be minus, so v square would be 2 times g times the displacement. Displacement is final position minus the initial position. So final position is h of t minus initial position is h. ठीक है बेटा? Yes. So v square is equals to 2g h minus h.
Yes, sir.
Clear, no?
Haan, sir.
So the last one, it was a bit of a lethargy, but I'm glad you pointed that out. Manan, Ruchika, clear ना बेटा?
Yes, sir.
हाँ, point out
Yes,
करना
sir.
बेटा, कभी भी ऐसे एक मेरी तरफ से error हो, तो point out करना, do point it out. Okay. So now we're going to talk about a scenario wherein the particle is moving in one dimension. It will keep moving in one direction, but it undergoes different acceleration for different durations. Right? So for example, if you look at the v versus t graph here, what does it tell us? This v versus t graph tells us that the acceleration for this segment acceleration is positive. With some value. Here the acceleration is 0. Here the acceleration is negative. Some value. Okay? Correct, Namita?
Yes, sir.
Okay. By the way, that reminds me, एक JEE Advanced का क्वेश्चन था पहले उसमें, I think एक क्वेश्चन टाइप या दो क्वेश्चन टाइप पहले, जिसमें it was a very interesting question. And I had mentioned कि आप लोग घर पे you guys should attempt it at home. Did you guys get a chance to do that question or no?
Sir, कौन सा वाला?
I'll have to go back. Which one was it? It was something to do with the particle covers, starts from rest, comes to rest after one, so at t equals to 0 it is at rest, then it again comes back to rest at t equals to 1 second, and it covers certain distance. I think it was whatever, a certain amount of distance it covers. So then you have to comment about the maximum acceleration or the average acceleration, whatever. But do you guys recall it was a multiple choice question? You guys?
Yes, sir.
Okay, you have done it, Beta? Ruchika, Beta, Chavi, have you guys done it?
No, sir.
Right, but you have to do it. No? That was a pretty classy question. You just cannot afford to miss some of the questions I ask you guys to do it. And Manan, Beta, how are we doing in overall your preparation? You are on target, on speed, knocking the questions down. Are you having a good rhythm, Beta? Everyday practice will matter.
Sir, कल एग्जाम खत्म होने से उसके बाद सर बेस बिल्ड अप करूँ.
Okay, but that's fine. That's fine. So when the students are sincere and they're working hard, then the expectations are higher as well, and it's for your own good as well, right? Just keep practicing, right? So the mind should develop the skill of figuring out the scenario, the complex scenario, and then of course the second part that mind struggles with is memory. That's where consolidation or revision or repeat study of the topics will become important. So there, your time management is very, very important. How you manage your day. Okay, you do not want to wait for the last 8 months nearing the exam. If you are getting into the last 6 months, last 8 months, if you are calm, collected, focused, if the ship is in control, then you will have a fun time with the exams. Though it's very hard to do so. But when it runs out of control, it's absolutely stressful. Okay? I want you guys to avoid that period. Every student thinks that it's nice and dandy and dekh lenge, will do it. No. But the last 6 months in 12th, they are not nice at all. Not nice at all. So you better develop good habits. By good habits mean make sure your mind is well disciplined, that you're practicing regularly, that your schedule is such that you are able to revise things well. Of course, I'll be helping in the consolidation part. But do not think that, yeah, I've always been able to pull off one-nighter, two-nighters, work hard and get good marks, right? This is an entirely different battle. This is not a sprint, this is a marathon. Okay, with that, let's move on. Let's solve the question or two. Let's take a look at this question, please. 2 minutes. You have 2 minutes to solve this question.
So 39.2 meter.
How much is it? 19.6.
So 39.2
39.2.
meters.
Okay.
इसे 29.4 होना चाहिए
9.8 into 4, huh? What is 9.2? 9.8 into 4?
So I'm getting 39 point.
39.2.
yes this is 39.2
Okay. So the velocity before it hits the water becomes 9.8 using the equation v square equals to u square plus 2gh. Good.
Yes, sir.
By the way, anyway, so maybe whatever I was going to say, we'll talk about it some other day. Let's carry on with the next question. Let's take a look at NT. These NT Abhyas questions are fairly good. Once again, NT Abhyas. Chavi, are you familiar with the NT Abhyas app?
No, sir.
Okay, so there's an NT Abhyas app that's available on the Play Store, and this is a app launched by Government of India or by the National Testing Agency (NTA) a few years back, and this one is for mock test, right? And most of the tests are full syllabus mock test, and so there you will find roughly about give and take somewhere around 300 different tests. So it is more tests than anybody can ever give, right? So they launched these tests in two phases. So initially there were 109 tests. These tests had 25 questions in every paper. But then NTA had changed the pattern, and they started giving out 30 questions, out of which 5 were optional, right? So the first 20 everybody has to do it, and the integer type you had a choice of 5 out of 10. So in the next roughly around 190 something papers, so you had 30 questions per paper. So what we have done is we have taken these questions. By the way, guess how many questions are there in total? Just for physics, there are roughly about 5,000 questions. 5,000 questions, right? Which is very difficult task to solve that many questions, and it's not really needed. If the questions are of the same difficulty level, for example, if the kind of question that you did, if you were to do 10 questions of this type, it's not really going to add any value, right? But still, these ones, the first ones, they were better quality. That's what we found. This one, I understand that the difficulty level has been reduced, right? But for the first 109, the difficulty level was somewhere between JEE Mains and JEE Advanced, though more close to JEE Mains than JEE Advanced. Right? So what we have done is we have absorbed all those NT-Abhyas questions in here. So there are about 2,700 questions, NT-Abhyas questions in the database. So make sure that you make good use of such questions.
So are these useful for us now, or like do we wait until we're done with a significant amount of portions to go and start using them?
Oh, no waiting, Peter. No waiting. You have to chuck through them right away. There is no shortage of mock tests out there these days, right? First of all, I mentioned there are 300. Can you imagine? Even if you give one test per day, they'll take you 300 days to do all these tests, which is just practically not feasible, right? And that even these are full tests. So actually, it is unfortunate that most of the tests students will not be able to give, right? They'll hardly be able to give 10, 20 out of 300. Yes? So there is no point in waiting. And especially the 109 in which the number of questions were 25. Most students don't take those papers anyway, but the questions are fairly good, so we've extracted them. Make sense?
Yes, sir.
Question.
सर आप स्क्रॉल डाउन कर सकते हैं।
सर डी आ रहा है।
Okay.
यस सर डी आ रहा है।
Okay.
सर वो जो लास्ट वाला सर डिस्प्लेसमेंट होगा सर वो 2s हो जाएगा।
वो 2s होगा।
सर 2s।
2s। अच्छा। Okay. Is this correct? What I've written here? Or have you guys approached it slightly differently?
सर मैंने सर s प्लस 2s प्लस स्क्वायर रूट 2fs की 15s लिख दिया था।
Acha, let me just explain better what this is. So the velocity at this point, by the time it travels a distance x, the velocity is v square is equals to u square plus 2as, right? A is f, distance is s, so 2fs, v square is square root 2fs. Then it travels at that constant speed, so the distance traveled will be square root 2fs times t. Now, after that, it undergoes deceleration from the velocity square root 2f 0. So once again, if I use v square equals to u square minus 2 into f by 2 into the distance, right? So the distance is now 15 minus 15s minus s minus this distance into f by 2 into 2. So this 2 cancels out. This is equals to v square or u square. U is square root 2fs. So that's what we get. So you get 12s is equals to square root 2f, and then t is out. Right. So if you square it up, so what do you get? 2 square, that is 144. S square equals to t square into 2 f s1 s cancels out, and 2 will give you 72. So we get s is equals to t square ft square divided by 72. keep doing more and more questions, beta, you will improve in the. Chavi, beta, is that clear?
Oh, yeah, sir.
Okay. Before we now close out, the session, let's take a look at some fun questions, okay? Number 2, please. So we'll not try and solve it. Let's just discuss these questions. So we'll take number 2 and then we'll take one other question. 2 questions. These questions are JEE advanced practice problems. So they are of good quality. So let's take a look at them. So they are the same level as JEE advanced level.
सर इसमें ए और डी में सर डिफरेंस क्या है?
Interestingly, I don't see any difference.
सर बस वो डॉटेड लाइन एक सर वो डॉटेड लाइन को एक एक्चुअल लाइन से रिप्लेस
solid
कर
line
दिया
दिखा
है।
रहे हैं. Yes.
सर ए हो जाएगा।
Beta, just
सर सर जो लास्ट लाइन है वो सर 10 पे एंड नहीं हो जानी चाहिए।
लास्ट जो लाइन है, लास्ट लाइन कौन सी बेटा?
अच्छा नहीं सर, सॉरी सर, ए ही होगा। यस सर, सर ए ही होगा।
So you better just give me a quick second, sorry. So I'm just scanning for some other good question that we can look at. Okay, so number 9 is another one that I want you guys to look at, and then we'll call it close.
सर इसमें सर डिफरेंशियल इक्वेशन सॉल्व करने को दिया है।
Yeah, beta. Just attempt that one, beta. Number 9. Chavi, beta, how are we doing on number 2?
सर आप रिपीट कर सकते हैं
क्या चीज रिपीट कर सकते हैं बेटा?
तो जो आपने अभी बोला।
हाँ बेटा, I was asking Chavi, Chavi beta, number 2, are we clear on number 2 beta? Are we clear on this question? How we would do this question, beta? Beta, you might be on mute. Ruchika, beta, just quickly walk me through the this graph and tell me why the answer is number 8.
Sir, can you hear me?
Yes, beta, I can hear you.
Yes, sir, it's clear. I've been speaking like I told you 5 minutes ago, but I think you couldn't hear me.
Okay, that's fine, it happens. So let's look at number 9 then, and let's solve this one. So let's pick up the pen and paper and with this question, beta. Number 9. And I just noticed that on the YouTube, Satyam, you have joined us. If I'm saying the last name correct. So beta, we are nearing the end of the session today. And just to recap what we have done. So today we have looked at the one-dimensional motion of a particle. And we have learned how to use the equations V is equals to U plus AT and S is equals to UT plus half AT squared for a couple of different scenarios, right? And what we call them as question types. So you might want to go through the video after it is published, which should be fairly soon. But we did cover about 7 or 8 or whatever number of questions today, so they might be of interest to you. But if you are in class 11th and if you have already done the kinematics in school or in your coaching, then I would encourage you to take a look at question number 9 as well. This is scenario with variable acceleration. Variable acceleration. So let's please take a look at question number 9. Even if you guys are not able to, so Chavi, Ruchika, Banan, if you guys are not able to solve this question in entirety, just walk me through the steps and then we'll take this question up 5 minutes prior to the class tomorrow. So please do join 5 minutes prior to the class tomorrow and we'll solve this question.
सर इसमें सर v को dx by dt लिखने का सर फिर डिफरेंशियल इक्वेशन सॉल्व करते हैं.
फिर क्या करेंगे बेटा, डिफरेंशियल इक्वेशन को सॉल्व कर लेंगे.
यस सर.
कहने मतलब आप इंटीग्रेट करते हैं, राइट? So that's you will integrate the equation, right, to get the relation between what and what?
Sir, X and
Sir, x and t.
X and t. The question says find the time interval between two consecutive instants. This equation tells us if you put v equals to 0, you will get x is equals to what will you get? Square plus minus square root of r by p.
Sir, r minus yes r by p.
R by p. So now you have to find out the time t when the particle is at x is equals to plus square root of r by p, and then time when it is at minus square root of r by p. So now when you're going to integrate the equation, right? When you're going to integrate the equation, p, q, r, they're all the constants. X is the coordinate of the particle, v is instantaneous speed. Find the time interval between two consecutive instants when the particle is at rest. Okay, so perhaps they have not defined from where they are measuring. Doesn't really matter. But when you're gonna integrate it, right? You're gonna integrate from. So we can assume that, let's say, plus r by p at time t equals to 0. And so you integrate it from 0 to t, and you integrate dx. You integrate dx from square root of r by p to square root of minus r by p, or minus of square root r by p. Does that make sense? No.
Yes, sir.
So we will not spoil the question. So tomorrow, 5 minutes prior, you will have to solve it in entirety, or you can solve it at home. Take a snapshot of this question, and then we can discuss it first thing in the class tomorrow.
Sir, would you be able to like take a picture and put it on the group, because I'm not able to take a snapshot right now.
Okay. Hold on, beta. Let's try to give me something else. Okay. So let's do the picture here. That's fine, but I'll take the picture. Let's take a break now. I'll see you guys tomorrow.
Thank you, sir.
Thank you.
Alrighty, take care, beta. Bye.